Good evening. Welcome to RASC Astro Cafe for Monday, April 13th, 2026. We are happy to have you here. Is there anyone online who is new to our meeting? Don't think so. Is there anyone in the room who is new to our meeting?
Nope.
Nope.
All
Okay.
familiar faces.
All familiar faces. That's lovely. All right. So I have on the list of presenters tonight, Natasha, Lauri, Randy, David Payne, and Peter Jedicke. Anyone else who has anything to share? All righty. Natasha, are you ready? Would you like to begin?
Sure, I'll do that. Can you hear me okay?
Beautifully.
Alrighty. So I'm just going to start with this image here. And there's a confluence of events like Moon Joy over the past 2 weeks. And coming up soon is International Astronomy Day. So I came across this little video that I wanted to share with you all. And if you hang on a second, I'm going to stop sharing and then resume sharing. I just wanted to start with that picture. Okay, here it is. It's coming up right away. Share sound, optimize. I'm just looking for the video that I thought I had up on my screen. Sorry, just hang in there.
Alex made it. What did you bring?
What are
Hey,
those?
we just got Bailey's something or others.
Ooh, chocolate?
Oh, yeah. Well, you wish you were here.
I know.
All right.
Okay, ready. This is a short video. It is 3 minutes and 18 seconds. And I have the sound activated, so fingers crossed. It has a very slow beginning, but then it gets going.
One night I was bored in my apartment and decided to take my telescope out to the sidewalk. The moon was out and I thought, why not? Within a few minutes, people started walking over and asking what this thing was.
Hey, what is that, bro?
It's a telescope. Do you want to check out the moon? Do you want to take a look at the moon?
What is it?
It's the moon.
How am I supposed to look?
You're supposed to look right here.
Oh, indeed.
Yeah. That's where it all started, and it just sort of went from there.
I'm looking at the moon. Hold on real quick. Hold on. Oh my god.
Oh my god.
Oh my god!
Oh my god. I can't believe it.
Oh my god.
Oh my god, no way.
No way. No way. That's the moon?
No way.
Yeah, way.
Oh, you can see the craters. Yeah. That is so cool.
Oh god.
Get closer, get wider.
Whoa!
What?
What?
Look at the edge. I want to see more of it. I know.
Holy. I've seen this before that is, man. Wow, that is intense right there, boy. Woo! Bro, that look like that's right down the street, man. Man, what you got here, man? That look like that's right down the street.
Yeah, isn't that amazing? It's right.
Is that an actual image of the moon? Is it like a live image?
It's that right there. To be able to see it up close and feel like you could almost reach out and touch it, and that's what makes it real to us.
That is incredible.
I kind of felt like I just landed on the moon.
It makes you realize that we are all on a small little planet, and we all have the same reaction to the universe we live in.
Wow.
Whoa.
Oh, wow.
Oh, wow.
Wow.
Yeah, wow.
I think there's something special about that, something unifying. It's a great reminder that we should look up more often.
So there
Fab-
you go.
Fabulous.
And
was
with
super.
the scope, it's a 12-inch collapsible Dobsonian reflector, and the eyepiece was a Teleview 13mm ethos. So, thanks. I hope you enjoyed it.
Thank you, Natasha. That brings a tear to my eye. Wow.
Yeah, that gasp that one lady made when she's looking at the moon. I love that. I get that all the time when I set up the scope, and it's just like chef's kiss. It's like my favorite sound. That first initial wow, there's something out there.
Yeah. Yeah, that's brilliant. Thank you for sharing that.
And Joe Carr is always looking up day and night.
Thank you. Randy, would you like to talk about the Science Fair and International Astronomy Day?
Well, I think after Natasha's film, we are going to start with talking about Artemis.
Okay.
It
Oh, all right.
suits the crowd, and it's funny, I figured this is Chris Gaynor's topic to share, but you know, it's also mine. I like the moon, so he's not here, so I'm going to present. So I just gathered a bunch of the images, and you know, some I just want to discuss. So the floor is open, is what I'm trying to say. So Artemis, very cleverly named, is Apollo's twin sister, and so it's very good to have that name. Oh, I was going to get a picture of the Sailor Moon cat. There is a Japanese anime which called Sailor Moon, and my student was explaining to me that she is the queen of the moon, but she has a cat named Artemis who gets them out of trouble. Anyway, there was a stuffy of Artemis the cat at the launch pad, and there is no picture of that in this deck. But there you go. Somebody else other than my student knows all about that. This was the moon on the launch pad. Now, they timed the launch so that it would be in the waning half of the month. All of the people who have flown around the moon were in the waxing part of the month. And I was talking about this with Phil. What somebody told me is if you're stuck on the moon, it's better to be there in the morning because that gives you more time to figure out how they're going to get off. but you had a different reason, I thought.
Oh, well, the other reason is that they needed a long strip of sunlit terrain so that they could observe landmarks as they're flying over them to check their trajectory. So
you want the low sun angle.
Yeah, right.
Yeah. So what we're saying is, it's like on Earth, your shadow is short at noon, but it's long at sunrise. So if you're flying over a bunch of pretty colorless rock, which is what we're going to be talking about with these astronauts looking at the moon with their eyeballs. But the main thing that you see is the shadows. And so if you're looking for the rims of craters and things, it's way easier to see at sunrise than at noon. And so that's the same thing that works in the sun. Anyway, it was around full moon when the rocket took off, because they wanted 6 days later for it to be well into the waning part of the month, so that they could see the west side of the moon. So that's why this is what the launch pad looked like. This was probably the night before the launch. Another moon picture, and this one was done, I think, in February, but I just like moon pictures. What crazy pictures of the launch. Just beautiful. I gather that a lot of the steam at the bottom is steam. That big water tower there is just spraying a huge amount of water over a very short time. And that's not just to cool the launch pad down, but it also muffles a lot of the noise. Because you've got, the whole point of a rocket is Newton's third law, right? You want to push a lot of mass one direction so that you can get your very big mass, the rocket, going the other direction. And that's going to make a lot of vibration and noise. Anyway, spectacular picture. And oh boy. Now, I don't even know how you do this picture. Is this it's huge dynamic range. Somehow you are seeing detail in the rocket thrust, but you can still see the rocket. I would have thought that would be black to do that. So this person somehow did a spectacular picture. Oh, this is supposed to be at the end. This is a mistake. So just keep that in mind, and I'll come back to that. But there's lots of great pictures of people looking out the windows. And Chris Gaynor's there, so especially you, Chris, if you have anything to add in, you're very welcome to interrupt. I just took a bunch of pictures this morning, and I'm sure you can add, color commentary.
Yeah, I didn't think we'd be home by now, but we just got here, so. But you're doing quite well, but I'll jump in if I want to, yeah.
You're very welcome at any time. Okay, so why is this such an amazing picture? And I think there's another one which is brighter. Yeah. But this is the nighttime. I mean, you can see particularly there is Payne, and you can see the lights all around the coast and in Morocco. There's all the bright lights there. This is nighttime. So, let's go back. It's a bit easier to see that this is nighttime here. There's just a bit of light sneaking around the atmosphere here. But also you got some nice aurora borealis up here and aurora australis over here. But this is a nighttime view. Where does the light come from? it's bouncing off the moon. That is light from the sun bouncing off the moon, which is like, it has an albedo of 3 or something, but it's bright enough that it's then sending enough light over to Earth. And I imagine that is Venus.
Yeah, it is. Yeah.
I was going to ask what the bright star is.
But there are versions of this where they've labeled all the stars. It's very good. I love this one with what's her name? Christy Cox hair flying around. They don't tie down their hair when they're out in space. Okay. I would think that would make you go crazy. You'd like it?
No, I put a band on her.
You'd put a band on it, yeah. I do like these interior views. And I wonder what makes a safe window. It looks like it's got 3 layers. That's how I'm interpreting that. But it's, you know, they can get hit by a little asteroid, a little micrometeorite, and you certainly want them to be strong. Okay, so yeah, there was a question from Wyman. The specific question is, while the integrity, the Artemis II was flying back to the Earth, was it to the right or to the left of the moon? And of course, we're talking in the northern hemisphere. And so the flight, I think it went around the Earth and near Earth orbit, but at first, but then they did an elliptical orbit, so it took quite a bit of time. I think it was a good day. So instead of like a 90-minute orbit close to the Earth, then it was quite a bit longer. And that was to give them time to try everything out, because this was an easy time to abort. But once they did this TLI, translunar insertion burn, so once it got back to the Earth after doing this ellipse, right at the back, then they gave it a good Zetz, and that set it on its way. And that was, except for navigation, that was it. That was the end of any big burn. And then it was on what you would call the left of the moon, and went around and came back around the right. Although, yeah, this is wrong around here. So let's keep going. And the reason I'm saying that's wrong, this is actually an accurate portrayal. And so when the integrity was within what's called the sphere of influence of the moon, so when the moon's gravity was stronger than the Earth's gravity, then it kind of did this backward motion around the moon, and that slowed it down so that it would come back to Earth. Okay, so it's a reverse slingshot. Jared came. Excellent. Is there a chair for him? We're going to talk to you about you later. There's a chair.
Thank you.
He came. Excellent.
You're,
He's our science fair winner. Okay. But for now, I'm talking about Artemis. Okay, so yeah, I guess, Chris, I would like you to talk a bit here about how it's using the moon as a slingshot, and how because they did this without a burn other than navigation. They left Earth with the translunar insertion, and that was the last burn. What's happening around here?
Well, basically they've been able to work out the effects of the lunar gravity on the spacecraft and accurately predict, where it's going to be coming back. This is not a first for this. This is kind of what they did during Apollo. The early Apollo flights to the moon all used this free return trajectory. Interestingly enough, later on, they started to move away from that so that they would have a bit more, they could go to landing sites that didn't fit in so well with this free return trajectory. And with Apollo 13, they had already moved off the free return trajectory.
Oh.
And then when they realized how much trouble they were in, they had a burn, maybe a couple of burns actually, now that I think about it, to get them back into the free return trajectory. I know they had a burn a couple of, maybe an hour or two after the oxygen tank explosion. And this using the LEM, but they also had another one which was quite major after they had passed by the moon, and that was dramatized in the movie, that particular burn, because they they were kind of using the seat of the pants means of figuring out, like usually with Apollo they would use they would navigate with the stars, but for this particular burn they decided to figure out where they were going by getting the Earth into this little telescope they had on the LEM, which I think they used for navigation, and using that, and that was dramatized in the movie. And it actually worked out pretty good, because somebody had thought about, well, what happens if this happens and our usual systems don't work, and so they were kind of ready for that situation. So it's just very, I mean, you look at that chart, and that gives you a really great idea of the accuracy involved in setting up these paths, because that gives you a bit more of a sense of the actual distances involved, instead of kind of the usual charts where you have the Earth over here and the moon over here, and they don't look like that they're that far apart, but they are very far apart. So I'll leave it there.
I just had a good thought. You know how, like, the Juno uses swings by the Earth and the moon to make the ship slingshot faster. So in that case, it would be like the ship going on this side, the trailing edge of the moon, and then the moon would add its velocity to the rocket and make it go even faster. But that's not what we want in this case. This time we want it going backwards, so going in the opposite direction to the moon. So the moon actually slowed it down. And that is the most important thing, because you got to slow it down so that it wants to lose the attraction of the moon and then come back towards the Earth. And I love that it's called a free return trajectory. They have names for all these different trajectories. There's a whole lexicon of trajectories to get between two planets or satellites, and this one is free. It doesn't take any extra burns. Now, I know in this display I took a lot of pictures of trajectories, and we're not going to dwell on them, but this is 3 days, 16 hours in. Here we are at 4 days, 22. 4 days, 23. So just 2 minutes later. So this is right around the closest approach. 5 days, 00. So Orion has stopped its momentum into deep space. So now it's going to start coming back to Earth. Okay, I'll just finish this. Now, here we are at 5 days, 2 hours, and it just so happens that Orion, why Orion? So the Artemis integrity. Oh, Orion is the name of the capsule. That's right. Anyway, had the ship launched in the previous two windows, there was a January window and a February window, and this was the March-April window. Had it launched before, then they wouldn't have had that eclipse, but just happened to be there. And then there's 5 hours 17, and it's homeward bound. And I think that's it for those. David, what's your question?
Maybe it's my memory, but it seemed like the Apollo missions took a lot longer in transit. Is that just my memory acting up? Because it just seemed like, how long was the mission? It was like 5 days or something, right?
My recall, it was actually longer, but Chris, I know, can answer.
Well, okay, this mission was 10 days. Now the first day was when they did that very elliptical orbit. So you can actually kind of throw that day out because they didn't do TLI until the second day. But still, it's a wee bit longer than Apollo. Like Apollo 8, Apollo 8 was 6 days, if my memory serves me right. Apollo 11, which included kind of 2 days of operations in lunar orbit, I think was 8 days, or maybe it was a bit more than 2 days. They spent a full day on the moon, and plus the time before and after. That was 8 days, and then you get into the latter ones, where they had these longer periods in lunar orbit, and also, longer times on the moon, but also they stayed back and in lunar orbit and they had mapping cameras on board. So the last couple were nearly 2 weeks.
Okay.
But yeah, this
maybe it was because I was a kid.
Yeah, that's right. That's right.
Okay, so cameras aboard, there were GoPros on the solar panels, which I thought was interesting because I think of GoPro as like a little $100 camera that people put on their bicycle helmets, but that's what they used for all of the pictures on the outside. And on the inside, they used 3 Nikons. One is the top of the line, what's it called, Z9, but 2 of them were D5s. They're like 10-year-old cameras. And what I understand is extremely high dynamic range. Like it goes up to ISO 3 million for the camera wonks in the crowd. And they've been taking them on the International Space Station for long enough that they know that they work. They've been field tested. Anyway, I love this picture. It's part the part of the moon that we know and love, and part that just is very exotic to us moon lovers. Another picture from inside, but again, the Oceanus Procellaris is very prominent, and the Mare Orientale, that big dot there, which is right at the rim of the moon, and then there's all this stuff behind that we never see. That's a better picture of it. Okay, so what do we see? Copernicus and Kepler. Up here is Plato and the sinus. Of rainbows, iridium. But then this is that very enigmatic Mare Orientale. It means Eastern Sea, even though it's in the west. And I bet Phil could explain why that happens. But there was a switch in East and West in the 1960s.
That's right. They received this name before that.
But why did they change East and West?
Well, because astronomical east really means sort of towards the east on the sky. If you were looking up at the full moon, east would be to that side of it, east on the sky. But when they were doing direct exploration on the ground, they wanted the cardinal directions to be the same as we're used to on the ground here. So they switched for direct exploration purposes. They use the cardinal directions. You know,
I'm gonna have to work on this one. I've heard this. It doesn't. I haven't integrated it. Okay, so on the right, the famous Apollo 8. Oh, what did they call this picture? Anyway, it's a great story.
Well, on it's the Apollo 8 moon rise and the Artemis II moon set.
Right. Anyway, the great story on the right is it wasn't on their schedule, and they had an argument in the cabin saying that's not on the schedule. And he said, just give me a color film. And he quickly put a color cartridge into the camera and he got that picture. And it's like one of the iconic pictures of all time. I don't know whether the Artemis II picture will get that sort of stature, but it's beautiful. And it's very nice seeing them together. So that's a little bit more of the moon set. And I just want to dwell on this a bit. First thing, remember I was talking about the Mare Orientale, that huge basin that we only see the edge of from Earth. Anyway, we have these lines of secondary ejecta. They're called catenas or chains. And I think that they're quite amazing. I like seeing the little catenas that you see on the front side, but you never see anything like that. And then you have this beautiful ringed basin here, and it's called Hertzsprung, as in the Hertzsprung-Russell diagram. And Phil was just telling me that you can't equate the size of a crater with how important somebody is, but I think Russell must be happy in his grave being called that. And then we have this beautiful pair here called Vasilov. And I don't know anything about them, but it's very nice seeing.
Vavilov.
What?
Vavilov.
Pavlov.
Vavilov.
Vavilov.
Yeah, 3 V's. Yeah,
3 V's. Anyway, they spent a lot of time in the cabin talking about it. And I was not glued to the live stream. I think Chris probably was. But just listening to them banter as they were looking at these things, what they had is they would have 2 people looking through the windows and 2 people taking notes. And they switched every hour for 5 hours. The whole encounter was 5 hours long, and they didn't want anybody to get too tired, I guess. So they gave them different roles, and they practiced this. They actually knew very well what they were going to be looking at because they had very good simulators in the lab. And I saw a picture of them taking pictures of the screen in their simulator. So they were totally rehearsed, but they still thought it was amazing. They were like kids in a candy shop. Oh yeah, and there was, how long was the period? It was like tens of minutes that they were in the shadow of the moon from Earth. And so there was no contact.
40 minutes.
It was 40 minutes.
40 minutes, yeah.
And that's a Vavilov.
I got it, yeah. Vavilov.
And Hertzsprung. It's nice seeing a new part of the moon. I like this. Get to know another place. This is a picture from a bit earlier on, but I like the 3-dimensionality of it, which you don't get looking at the moon from home. Okay, so what's going on here?
That's the eclipse of the sun by the moon.
It's the eclipse of the sun. So the next question is, why is the moon lit? If there is, like, when we see the eclipse of the moon on Earth, the moon is perfectly black. Actually, that's not true. there are some very high, what do you call it? High definition pictures where you can see the Earth shine on the moon during a solar eclipse year. I've seen that. But here, that is again the Earth shine, but just on the side. So it's a crescent moon made out of Earth shine. I think that's wonderful. And then this is the corona of the sun. And then we have, oh, I know I put this on. Saturn. You can't see Neptune, but there's Mars and there's Mercury. And you can see that Mars is visibly redder than Saturn and Mercury. And then there's another picture where Venus is off on the left. And I love it that they put them up with little paper solar glasses. Like what? NASA didn't want to spend any money on some fancy glasses?
No, it was just cute. I'm sure.
Too much weight.
Yeah, too much weight.
Yeah. Looks like they're watching a 3D movie.
And do you know that those glasses were designed by an optician in the University of Western Ontario? Actually, Peter, you would know the name. It's
Ralph Chu.
Well, very good. Chris knows.
But he's at University of Waterloo, not Western.
There you go. Thank you. But they're being used like by the millions, these glasses, and they were designed to be very cheap but very effective at protecting people's eyes.
It looks like they're watching us, and those are X-ray glasses.
Oh, and then I jump right to the end.
Yeah.
Except for that picture that I'm going to have to go back to. So the great picture at the end. I'm pretty sure that was the last one. So we're just going to zip to a picture that I just found this morning. I love it. This is from the International Space Station. This is them looking out the window at their friends across the sky.
Is that re-entry?
Yeah, that during re-entry. But I didn't put it in the right place in the thing.
Cool.
That's cool.
Okay. So I'm not going to stop my share because I'm going to introduce Jared after this, but any other thoughts and hopes about Artemis? Yeah, Ken.
There's an extremely good video of the launch. It's done in stabilized high definition, and it's near infrared.
Oh, yeah.
Yeah, worth looking at.
So maybe we'll try to line that up next week, or if we get bored today at the end.
And I was just going to say, Randy, I don't know about anybody else, but my heart was just in my throat until the three parachutes came down. And as soon as they came down, I went, okay, I'm fine. But I wasn't. I was pretty nervous until everything did it, I must admit.
For me, my heartbeat was when there's that 6 minutes that it is coming into the atmosphere so fast that it's ionizing all of the atmosphere around it, and they lose radio contact. And it's only once it's slowed down enough and they don't have this plasma that the radio waves can get through, and they can say, we're here, we're still alive.
Yeah, that was pretty tense. I was watching that.
Okay, I saw a Chris question from who was it, and why didn't you put on your voice and ask it? I missed who was asking the question about 2030.
Marvel.
Murray Leslie.
Oh, yeah, that's me. Sorry. So what how realistic do you think it is that there'll be a manned base on the moon? That's what the ultimate goal of this Artemis project is.
Definitely a Chris question.
Well, it's So they hope to start landing in 2028. The base will probably follow a few years behind that, but that really, when you get down to it, that's kind of a question more about politics than anything else. You know, by the time we get into the period where the base should be going up, there will be a new administration in place, and we can't predict, is this going to be a follow-on to the current one or a different party, and what's their attitude to space and spending money on space, and whether we might get into how much interest there is from the private sector in getting involved.
Well,
So
so I understood that SpaceX was going to be sending multiple ships to the moon to lay down all of the material that they would need, and fuel and oxygen and everything that they would need. But eventually, they would be, from what I understand, using the frozen ice to manufacture both oxygen and fuel.
yeah. So that's
It would be
that's
a wonderful thing.
that brings up
We're all old enough to remember as kids. This is what we read about in science fiction books, right?
Yeah.
And we might see it in our lifetime.
Yeah.
So Chris, I'm going to push you on Murray's question. You're allowed one number, 1% probability for 2030 having a base on the moon. Is it 1%, 10%, 50, 90?
What is
2030, I think is very, very low. I think it's probably fair to ask, give me a bit more time, 2032 or 2033.
Oh,
and
okay.
I would say maybe about 30%.
30% by 2033. Okay, guys, we got to remember this.
We need to book a party at you for it.
Yeah, party for that day. Okay.
But that's really, throwing the dice. There's a lot of factors involved, and we'll see.
There'll be a Trump hotel on the moon.
Ouch.
No, well, if he stays there, that's fine.
Okay, Susan Grady.
Yeah, I had a couple questions. The picture of the Earth where you were showing the aurora.
Okay.
The way it seems to me is that the Earth was upside down, because you had the North Pole at the south end and the South Pole at the top end. And
this is the Sahara Desert. That's Iberia, Payne. So absolutely, it's upside down.
Maybe we're upside.
But it doesn't mean anything when you're on the spaceship. There's no.
Yes.
You just turn yourself around.
Yeah.
But it's not like your feet are Susan's moving around.
Yeah.
But Joe actually posted a picture of it put north up. And I was watching these two YouTubers from Los Angeles. They're very funny talking about the mission. And they were saying that the only reason that we say this is upside down is because a bunch of white guys from Europe decided to make Europe the top of the world. And it's
okay, so with
kind of
that
correct. There's no real reason that north is up in our maps.
Okay, so with that reasoning, then, when we look at what we think is the top side of the moon, that could also be wrong.
Well, it's not that it's wrong, it's a convention.
Okay, convention then, but
there you go.
Okay, so that's a better picture.
Yeah.
Or maybe it's having the aurora at the north might be the thing. Anyways, but that's Spain. There is the bulge of the Sahara. So I suppose over here somewhere there's some South America.
Yeah.
And over here would be Newfoundland, I guess.
Oh, all right. Okay, that helps.
I'm sorry.
Could I make a couple of comments about that? There's the aurora in the north and in the south in these pictures. And I don't know, Randy, did you talk about the discussion that's going on about the glow in the background there? Whether it's how much of it is the sun's corona and how much of it is zodiacal light?
Oh, I didn't, but that's a really good point. They were calling it zodiacal light when it was behind the Earth, and they were calling it corona when it was behind the moon. And I haven't followed up on that. What do you know?
Well, it's just at least in the NASA captions that go with these pictures, they noted that glow was being attributed to both, and that there was a lively discussion amongst the scientists about how much was from each. So this is this is one of the things, one of the discussions that's coming out of this whole thing, this mission.
That's really cool. But I did note that here it's called zodiacal light, and behind the moon it was called corona. And I did a whole talk about zodiacal light when I talked about Brian May's thesis about a year ago. So I'm sure there's a recording of that. But basically, it's dust that's coming off Mars into the plane of the planets.
Randy, the other question I had is, all the pictures seem to show that piece of the Sahara, and I'm curious about why we're not seeing another side of the Earth in their photographs. Is that because of when they were able to take the pictures?
Wow, I hadn't thought of that.
Mm-hmm.
They had a lot of time to look at the moon because they were in that elliptical orbit, and it took a day. I mean, this particular picture is because it was when they were behind the Earth, and so they were only getting moonshine. That's the interesting point about this picture, is that it was when the sun was antipodal. It was on the other side of the Earth. And so there was able to see the moonlit part of the Earth really well. So that's why this is such a great picture. But I think if we...
I'm going to throw in another comment if I could. So these, these photos, of course, the Earth is all dark, and then they've been kind of brightened up. But most of the other pictures, yeah, you have these half Earths, but as they got further and further out, there were more crescent Earths, as we saw in the Earthset shot that Randy was showing. So that was, the Earth is kind of, as they get away, the Earth is kind of turning below them. But those most of those missions or those photos we were just talking about were taken very soon in the early in the translunar coast.
Mm-hmm.
And then we get out by the moon, and it's a lot of crescents, but
there's a great picture of Antarctica. I didn't put it in here, but there's an absolutely wonderful picture of Antarctica that I cut out. It will be in here. So part of the problem, there's so many fake pictures that you really have to worry about how authentic they are. This one I wasn't 100% sure, and it looks like I deleted it.
Wasn't that our Antarctica in the picture you were just showing?
Oh, the one I was showing, I couldn't see any land.
I thought that was Antarctica.
Oh, it
It
could
was a
be.
different color than the clouds. Like it was a different shade. That's what I thought I was looking at.
So, I do not 100% guarantee this is a real picture. It is quite spectacular. And what they say, this is, I guess, a reg question, is it's just so cold around Antarctica that you don't get clouds. Does that make sense?
I don't believe that one. I think that's AI.
Okay.
It looks too bright. It looks like it's been, I don't know.
Well, let's think about where the Terminator is. Since this was taken not very long after the equinox, the Terminator should be pretty close to the pole. So I don't think that that's a correct picture.
It's a fake.
I think
Well, okay, I had misgivings, so that's why I didn't show it.
Yeah, that would have to be a winter picture for us or midsummer for them.
Right.
That's a suspicious picture.
Yeah.
You know, the Apollo 17 Antarctica photo was taken in December, right? And but we've seen all those photos on the internet, you know, of Oriental with a hell of a lot more relief.
Oh, it's crazy.
Than
It's
reality.
There's so many fake pictures. And I try to use a bit of reason to figure out whether it's true or not. But yeah. So that one's a fake. Good. I was really very worried about it. So you think this is Antarctica?
It's either a reflection, right?
Oh no, that's the specular reflection.
Yeah. Oh, that's a reflection, is it?
That is the sun bouncing off like a mirror. It's the straight reflection, not the kind of rough surface. Yeah, you always get that. But that's a good observation that is something you got to kind of filter out with your brain when you take a look at these pictures.
Yeah.
Joe Carr writes that NASA Johnson is a good site for official photos. And so we can count on those not being fakes. Is that what you're saying, Joe?
Yes.
Yeah.
Yeah, that's what I was just going to say is you'd have to really go to the NASA sites, like the good ones, to be able, and then just don't try to do anything else.
Yeah, it's really tricky.
Well,
okay.
That's life too. Like any picture.
Yeah.
Be careful.
So I am actually going to stop my share because now I'm going to switch gears and say that for the last 2 days, Lauri, David Lee, and I were at the Vancouver Island Regional Science Fair, the 65th. And it was wonderful. It really was a very, very good fair. We had 115 projects, 150 kids, grade 4 to grade 12. And I was really, really impressed with the prizes, but one that I was particularly keen to talk with was the number 2 in fair, Jared Chin. Is that how you pronounce your name?
Yeah.
Like with a CH sound?
Yeah, Chin's fine.
Chin. How do you pronounce it?
It's really hard.
Give us it.
Just say it.
It's easy for me.
Say
But
it.
nobody has gotten an nobody has really got okay. Qin.
Scene.
Qin.
Scene. Okay.
Wait, he got it correct.
Well. Anyway, Jared, I'm going to embarrass you. Can you walk up towards the camera a bit so that people can see you?
The camera's on the bottom, TV on the left.
Oh yeah. And then okay.
Hey, Jared.
Hi,
I
Jared.
know that Dave got to talk to you. I don't know whether Lauri did.
No.
Lauri? Okay. that's
No,
too
I
bad.
did speak to Jared. Yeah.
And I spoke with him quite a bit. Now I'm going to ask you to come here, but I'm going to also set up. Oh, no, I have to share my screen again. Here we go. Let's share my screen. And without any preparation, Jared has accepted to talk about his project. So I'm going to ask you to come here, okay? And you can kind of navigate about this if you like. Here we go.
Oh, okay.
So,
wow. Really soft.
So I go like that, and it's actually better looking on the screen.
Yeah.
But the floor is yours. You can talk, and and as you see, people like asking questions here. Oh, what grade are you in? What school are you in?
Oh yeah. Hello everyone, my name is Jared. I'm currently a grade 10 student at St. Michael's University School. I had the fortunate chance of being able to present at the Vancouver Island Regional Science Fair, and turns out I was the only astronomy project there, or something. But okay, so
Yes, we wanted to hand out 2 prizes, but there really was nothing else that we could even stretching it.
Move the microphone.
Move the microphone closer. There we go.
Okay.
Yeah.
So, my project was about discovering hidden galaxy mergers. So, I trust I don't have to do any of the why astronomy is important spiel with you guys, but everybody knows that like the previous like James Webb Space Telescope, like the Deep Sky Survey, we found like the supermassive galaxies that weren't supposed to exist, and I felt that one of the like the current a lot of like a big hypothesis was that we're miscounting the galaxy merger rates. So after doing some data analysis and background research, I found that 6% of all galaxy mergers are completely invisible to every standard detection tool. So basically, my hypothesis was I was gonna create a machine learning classifier using this ratio that I'll talk about in a bit, and I'm gonna train it on simulated data, and it can find mergers that are invisible to all current standards and current methods. And a study done by Buon in 2025 found that like 71% of all galaxy growth in the early universe was created by galaxy mergers. So this is like a pretty significant problem. And after I did some more research, I found that there were 3 main reasons why these galaxy mergers are invisible to all of our current standard methods. So there's a few reasons, but the first one is they're too massive. So basically, one of the main ways these classifiers find these galaxy mergers is because of like the irregularities in the mergers, like the gas that gets spurred out, or like just how ugly it looks, basically.
Do you remember when Sarah Ellison talked for us? She really likes these ugly galaxies that come from these collisions. Oh, and Sarah's student was your mentor.
Yes, Dr. Wilkinson. Yes, Scott Wilkinson. Yeah, so when they're too massive, all this gas like gets sucked into the deep gravitational well. And then another reason is when there's no gas in the ellipticals, maybe because they were previously a merger and all the gas burned up, or there's just not enough gas in the ellipticals in the first place, there's just no gas to spur out of, so there's no visible signs. And lastly, for like the red sequence, they're just old and quiet and you can't really see them anyways, no matter if they merged or not, kind of. But basically, I designed my classifier to specifically target the first 2, the ones that are too massive and the ones that are gas poor. Because for those types of mergers, the center either settles fast or there's no change. But when they are merging, there is still some remnants in the gas. So if you look here in this schematic, the dotted line represents like the remnants after the merger. And basically, yes, current standard methods can find these pre-mergers and they can find these active mergers because both of the they can't find pre-mergers. They can find these active mergers because there's signs, but when it's a late remnant, because these standard methods are only looking at the middle and the center, they're not checking this like outside gas remnants. So I designed my let me see if I can see here. Yeah, okay. But I designed my classifier around one, like current classifiers use this metric called asymmetry. So basically, you take a picture of a galaxy, flip it 180 degrees, and then you remove all the common pixels. So this shows you basically how ugly it is, and this is all the irregular parts. But as you can see slightly here, there's a circle. So most current classifiers, they look at this center circle, but they miss this outside ring. So because like each pixel has a number representing like the light coming from it, it's basically like a number. But they're only looking at the number from the center, but I can look at the number from the outer asymmetry. So then I get this number that's called AO/A. So basically, this ratio is actually like a really big key sign, and this ratio basically tells us is the outside messier than the inside. And as you can see here, after I like ran out simulated data and did some data analysis, I found that it is indeed a trend. Like all of these orange, this bar-ish orange bar is all hidden mergers, and all the blue one is current like final mergers, and all of these hidden mergers have a trend of having a higher AO/A ratio. So basically, I implemented this into my method. I trained my classifier on simulated data and real data, and some measurements on it, and then I found a bunch of like results and signs. And then one of them was the AO/A ratio, and then I implemented it into my machine learning classifier after I tested a few different types of algorithms, and I achieved 89.8 AUC, area under the curve. It's kind of like accuracy. But so after that, I ran it on 66,000 real galaxies, and then I found 301
from the Sloan survey.
From the Sloan Digital Sky Survey. It was just so easy, and it was right there. And there's all the code is like really already built in, like JWST. There's like also plugins, but when I was like small and I started just learning how to use coding, I like learned how to like access Sloan Digital Sky Survey data, so I just chose to use that one. And then I found 301 potential hidden mergers candidates. So then I validated my results with Galaxy Zoo. And then I found 272 of them were in Galaxy Zoo, and 152 of them were classified as mergers. And so basically, a lot of the mergers that I found were indeed actual mergers, and humans said that they were mergers too, but just the classifiers all said no. So in conclusion, I found a systematic blind spot like 6%. I identified a few root causes, and then if you look at this graph, basically this is a ROC curve. Basically
ROC.
It's basically okay. So area under the curve is basically like it's like the area under this curve. It's basically like you could say accuracy, which is 80%, which is basically like 80% of the time I can get this thing right. But 80% AUC is like basically accuracy, but it's a lot more specific. Like when I am making this choice between merger or not merger, and I do this 100 times, 80 times it will pick it correctly. It's like really similar, but basically my curve was on the top without spectroscopy. And this black star is Dr. Wilkinson's benchmark, and it is higher than mine. So you might wonder why I even put this graph on in the first place. But it's because his classifier uses spectroscopy, so they have all these fancy data like chemicals, like specific relative redshifts and stuff. But that like takes time and takes like a huge queue, and you can only do a few galaxies at a time. So I chose to sacrifice some accuracy just for it to be able to be used on a lot of images. Thank you for listening to me.
Great.
Anyone have any questions?
When did you start coding?
I started coding when I was 10 years old.
Okay.
But
Explains it.
mostly because my dad was a computer.
I know. It seems to be something in the DNA. Yes.
Leslie, that's right.
How does the classifier work to screen out galaxies which are at different distances?
Yeah, so this is basically this is one of the reasons why I included 13 different features. So basically the A standard features, their asymmetry, which we talked about how ugly it is, outer asymmetry, which is the gas outside if it's messier, but there's also AS, which is shape asymmetry. Basically, like you cut it out like a cardboard and it's just like the shadow of the galaxy. But that can it's like super protruding, like if it's like a round object, but it suddenly like protrudes like this, that means that there's like not a lot of gas exchanging between those two objects, which means either it's really far away, it's not interacting it with it at all, or it's just really, really bright. But that's one indicator. And G and M20, those don't really help us discover that type of galaxies, but they're basically how, number one, how scattered the brightest 20% of the pixels are, or how far away are the brightest points on this picture are. But S is smoothness. I don't think those help us either. But okay, but these are like center features, but the shape helps us, is an important one. And also, I don't think Cersei again helps us either. But basically, like, to prevent that, like, the difference between like a galaxy and like a star very, very far behind in the middle, basically first you're gonna there will be some gas exchange in the middle, and that's how my classifier finds it. And just because of the gas exchange between the two objects, it'll flag a few of them. And if it doesn't have gas exchange, maybe one or two of them won't flag. And I only had 301 hidden merger candidates because I had a really, really high bar for them. The first step is that all of these features, plus the 5 features that I added, all have to say yes. And then every single current benchmark on the, like, at least like the 4 to like 10 that I tried, all of them have to say it's not a merger. So that's like how we basically find it.
Okay, Jared, your outside asymmetry divided by the inside asymmetry, or the other way. How do you define the size? Because the more distant galaxies are much smaller. How are you defining what's inside and what's outside?
Yeah.
And not getting into where you're getting interference from other galaxies and things.
Basically that is a lot of the times it's just up to the classifier. Sometimes when they make the radius too big, I have to deal with like the outside galaxies and like worrying about if it's a galaxy very far away or if it's a satellite galaxy, because I'm looking at the outside gas. But a lot of the reasons why a lot of classifiers don't choose to include it outside is just to avoid that circumstance. So each classifier has, like, for example, like Lintot, like Dr. Wilkinson's classifier, like all of their classifiers, they all have like a different radius range. So it really like varies a lot.
But you did 66,000, so you didn't actually choose each one.
I didn't actually choose each one. But I choose each one as in choose each of the
choose how big a window.
Choose a window. Yeah, I compared it to the Dr. Wilkinson's one radius. Yeah, because his is star above me. I really tried. I really tried.
What's your underlying classifier? Is it like OpenCV, or what are you using for classifier? OpenCV?
I use some of that, but also it mostly comes in PKL files, but I use machine learning classifiers. I used linear discriminant analysis. I used gradient booster, and I use random forest. I only use supervised training algorithms because all of them, first, they work a lot better with labels, and all my data is with labels. And second, if I did have around 93% AUC for unsupervised training. I just wanted to see if it did better for the and giggles, but basically it did have a higher accuracy, but I didn't want to use it because I wouldn't be able to very specifically see the parameters it did and all the weightings that it did. So
yeah. What hardware did you run it on? What kind of hardware did you run it on? Did you use like a Lambda or some of the cloud service?
What computer did you use?
Most of the hardware stuff was done by my dad.
Okay.
I just coded the software stuff.
Sorry.
No, but what computer was it run on?
On my dad's computer.
Okay. A PC?
Oh yeah, a PC with the GPU. Yeah.
Okay.
Yeah, I was just going to comment on that. I remember asking Jared about that because I thought for sure he had used, some kind of cloud service like Collab on Google or something like that. But then he told me he used his dad's computer.
Yeah. My dad has this super hardcore. He's been like stuck in this like superhero computer for like over 10 years, and he like always buys like new things to it. So I was just like, can you just take care of it?
You can always rely on your dad.
Yeah.
Okay. So was there another question? I thought I saw.
No, that was me, Randy.
Okay. Well,
I have a question for you, Jared.
Yeah.
What made you choose this particular topic?
Basically, I've always wanted to get into astronomy research, but since I never really talked to a lot of big researchers, I never like was like, oh yeah, I just know what to do right now. And I couldn't really understand papers when I was really small. So it wasn't until I went to this big like international competition and they had this academic conference at the end, and then I met Dr. Wilkinson and a bunch of other researchers there, and I heard them talking about like these problems, specifically the supermassive galaxy problem. And I'm like, oh wow, wait, that's really interesting because I was kind of just like, I just watched astronomy YouTube videos before doing this, so I didn't know a lot about the current issues, but after that I learned about the current issues, and then Dr. Wilkinson was like, hey, you should look into galaxy mergers. So that's how I got into this specific idea.
Wow.
Thank you.
That's wonderful how she took interest in you.
Yeah.
I would like to say that Jared has accepted to have his poster board up at International Astronomy Day on the 25th. So that will be one of the tables. So thank you.
Yeah, thank you for
That'll
having
be
me.
great. As you see, we don't have enough young people in our community, so we hope.
Thank you, Jared. Thank you
We
very
hope we
much.
don't scare you, and that you do enjoy spending some time with us. But I've been talking enough, so I'd love it if somebody else, David and Lauri, and Ben talked about the International Astronomy Day.
Okay. Jared, that was brilliant. Thank you so much.
You.
All right. Lauri, would you like to talk about International Astronomy Day?
Well, I'm going to actually turn it over to David because he's the one who's been doing some of the he's been doing the posters, and maybe he can show what he has. Can you do that, David?
I think so. Or Randy, do you have the poster handy?
Oh, yeah, I can post it. I can put it
Or
on.
or can you bring it up on your computer?
Yeah, that's what I'm going to do. That's what I'm
Yeah,
going to
that's
do.
great. Well, while Randy's doing that, yeah, we've been kind of madly trying to assemble all the pieces. Thank you, everybody that contributed. I think we have a great lineup of speakers, and big thanks to Joe for taking stuff all of a sudden and then magically making them appear on the website. So yeah, as I guess as Randy brings up the picture, this poster you'll probably recognize, as I mentioned to
this
people.
is the small one. I
Oh,
want to
that's
get.
okay. That's okay. I mentioned to people is I've been repurposing this poster probably for the last I don't know 4 or 5 years, and I've been oscillating between round circles for the speakers and Polaroid templates for the speakers. And this year is a Polaroid year, so yeah, it's great. We had and you know I'm so happy to have people like Chris and Dennis and Megan and Lauren as our speakers. And big congrats to Megan. Is Megan online?
Yes, hello.
Yeah. So yeah. So thank you so much, Megan, and I'm so pleased that you're going to be speaking, and a lot of the activities that people love are there as always. We're going to be short Sid for the solar, so I'm a little bit sad about that. But I understand Chris Purse has been organizing a big solar team, so that's great. Astrophotography, as always. Dave Payne will be there, and amongst others. I think Gary might not be there, but I think there's always going to be a team of imagers there.
We have 6 imagers lined up.
Excellent. So Gary, you're not going to be there that day, right?
Yes, family duties pull me away.
Family duties.
I'd rather
Okay.
be there, to tell you the honest truth.
Couldn't you make an excuse and just appear?
David.
Yes.
David, Kathy is taking a picture of the screen. I think we better email this out to everybody.
Yeah, I've got a big printable version, which is usually too big, and I mentioned
but
Mhm.
make sure everybody has a copy in Sky News.
Yes.
Yeah. I can certainly do that. The little guy is better to place in smaller places. Laurie, is that correct that more places that would be willing to take the 8.5 by 11 than the 11 by 17?
Yes, most places will let you put up an 8.5 by 11. The other one is a bit big. Some of the if anybody has got the ability to go to some of the community centers like Cedar Hill Rec or something like that, then they often will be able to put up bigger posters on their poster boards.
Mhm.
But the smaller ones are better at in some of the other spaces. So.
Gary, you have your hand up.
Yeah. So, Astro Imagers, I'm going to be scarfing a bunch of photos off of Zenfolio. So anybody that doesn't want me to use some of their excellent shots, please let me know. It's easier to ask to do it and ask forgiveness later. It's my philosophy.
All right.
Joe just posted that it's on the website, the printable version. And I'm really sorry, I printed 20 copies that were going to come here tonight, and they're still at home because I came home from science fair and went straight to sleep.
Yeah, let me know if you're like what people can do. They don't have to take them anywhere. Just give us a list, and then we'll somehow get them to these places. If you can find places that will accept them and take them.
And if I'm a good boy, I will bring it next week.
Okay.
Then, it's the last week is when it really matters.
Yeah. Now, Ben, are you online? I think you are, right? Ben, are we short some activities in terms of volunteers? It's never too late to volunteer. Ben,
Yes,
Ben, what
yeah.
do we need? What do we need, Ben?
We need one or two more people on Chris's Artemis II table.
Oh, let's speak about that a bit. There are two new tables this year.
Yeah.
We're going to have one that specifically focuses on the Artemis missions that Chris is spearheading, but Chris is speaking for one of the hours. And bye. And anyway, we want to have more than one person at each table. So this is going to be a table devoted to Artemis, and I don't know, we'll have a screen with a bunch of pictures on it, and we want to have somebody who just likes it. You don't have to know a whole bunch, but it's somebody who's keen on talking about Artemis. So we would like, I don't know, probably one or two people to go with Chris on that.
Now, Chris, maybe you can answer this question. Are you still planning to bring some models to the event? Is Chris still there?
Yes, he's muted.
Oh, he's muted. Okay. Well, maybe when he come back
Yes,
online, he can... okay.
Yeah, I'm still planning to do that. And I'm sorry, so I've been away for a few days, and of course 3,000 emails from all directions land on me as soon as I step out the door. So I see you've put up something about my Hubble talk.
Yeah, I have. I'm missing. I don't have an abstract for you, and I don't have a very good picture of you. So I know that Joe found a picture
I'll try
of you,
and sort
but
that out in the next couple of days.
that would be great. That would be great. And I think the other thing, Chris, we were looking for is the last press release, the one that is issued maybe a week before.
Yeah.
Yeah, we'll be waiting for that, I think.
It was out in the Sunday issue of the Times Colonist.
Very good. Now, Lauri.
Okay, and I'm going to need some material for the last press release. Like, do we have more speakers? And do we?
Yeah, we do. We do.
Might be able to put on the radio or something.
Yeah, so Chris, maybe we should have a chat over the next couple of days. I'm also hoping to do some video clips, maybe either from speakers or some of the people that are doing activities, just short things that we put up on social media.
Right. Okay. Yeah, so that we can do that offline here.
Yeah,
okay.
We can do that
and
offline.
Mary Leslie is asking where it is. It's at the Royal British Columbia Museum from 10 till 3. And so we'll be setting up just at 9 o'clock or so. And you'll come but that's great. So Ben, I hope you got that Murray is keen to help.
Well, for everybody, for more info, go to the recently set up website that Joe has put up. It has all the material and more than what's in this poster. So the details are actually on the website. And in fact, the posters now are mere just ticklers for people to remind people that it's going on. The detail will be on the website from now on.
Okay, and then there's another table, which is Lauri's inspiration, because there's so much stuff to get rid of at the center of the universe, and especially at Sid Sidhu's garage. So, Lauri, do you want to talk about the giveaway table?
Yeah, sure. So usually we have a few things that we give away at the welcome table, but I want to add a few more things to that, and I didn't want to take over poor Jeff Pivnik to have to give away everything. So I think we're just going to have a table where there are books and magazines and posters, and we've got all kinds of things that we would like to just simply give away. We're not allowed to take any donations at all at the museum. So they really are, if people are interested, they can simply take them away. And then we'll pack things back all up again and take them up to the center of the universe in the evening. And there we can put up a donation jar and just say, throw in a loonie or something like that, and you can take away a book or a magazine or something like that. So we hope that maybe some people might put in a little bit of a donation for that as well. But if any of you if you're coming down to the museum, and I hope everybody will, is that if you've got a couple of books or something that you do want to put on the table, please bring them down. Everything needs to be in fairly decent condition. I don't want to give away things that are, falling apart. But if you've got anything that you'd like to donate to that table, that's great. And we'll need a few boxes to put everything back up at the center at nighttime. So
Lauri,
that's the other table that we are going to put up. Yes.
You said you had like 100 Apollo 13 movie posters.
Yes, I can give Apollo 13 movie posters to every single person that there is here. Yes. Yeah, they have the IMAX have them, so I've got all kinds. So
yeah, there's all sorts of manufacturer swag as well. I think, don't you have like a collection of Celestron toques and stuff? Or
I think I'm not giving those away. Those are going to be very
those are going to be
special.
prized things,
totally.
eh?
Yes, exactly.
Okay.
So the other thing that we do need a couple more people for our craft table that is going to be on. We've got a couple of people that are going to be doing that, but we do need a couple of people who don't mind kind of working with some little people for a little bit, and families, and that would be wonderful, because we do need to have people helping there for sure, and we could also use another person for sure at the Stellarium booth. We put down we have people doing maybe an hour at a time or something, and you're just chatting away using Stellarium. So you do need to have like a little bit of some knowledge, like some basic knowledge of how Stellarium works. You don't need to be able to kind of do absolutely everything on it, but you're just chatting away to people and showing constellations and what's up in the sky today, and that kind of things. But so we do need to have a couple of those people, and I think there was something else. Alex,
no,
are you guys okay outside? Do you know?
Yeah. We just got another Jim Cox has volunteered for the solar telescope, so we're
Terrific.
okay for that
Okay,
now.
so I think we'll be all right.
Yeah, excellent.
Yeah, so
it's very important.
It's three of them now.
Yeah, it's really important to have enough people out at solar, because in actual fact, the instruments are kind of dangerous if they're mishandled. So I would really recommend, like, even if you don't know how to use a solar telescope, please come and spell off the people that are actually using them, because we would not want any of the telescopes to be left unattended, right? That would not be responsible for us to do that. So please do that. And the other thing is, if you've thought about maybe helping out, but you don't think you know enough to do so, I want you to come anyways, because there's a real merit in you coming. Like even though you don't do an active thing this year, next year you will. So I want you to come out and for any of the activities, whether it be responsible lighting, the planetarium thing, the solar stuff, just come out. We can certainly use you, and it just makes it a much larger and nicer event. Sometimes people just want to chat, right? Right, Lauri?
Yeah,
Just talk
absolutely.
about
Yeah.
astronomy, right?
Now, the one thing I do need, and I have not set up yet, and so this is like a 2-week notice, is in the morning. So this is for a person who likes to get up fairly early. Is we open the museum, like they open the museum for us at 8 o'clock, and between 8 and 9, we can put our cars up with anything that you're bringing in. We can bring our cars right up to the back doors, and so they don't need to be hauled anywhere really a long way. They just need to be brought up. I need to have a person who wouldn't mind helping with kind of looking after the like the passageway where we lift a what are they called, a bollard,
Yeah.
and let cars up, and we just have to make sure somebody's, I mean, I've got a safety vest, and you just have to make sure that there's no pedestrians that are walking in that area while the cars are coming up. And then that is between 8 and 9, and it would be really nice to have somebody who wouldn't mind doing that job for me, because then otherwise I'm usually at the back door. Oh, Murray, yay, thank you.
Excellent,
Thank
excellent.
you. I'll
And
put
and
you-
and I
put
don't
you down
want
for
to
that.
I don't want to underestimate the importance of that role as well. Safety is really important. There's a lot of moving parts, a lot of
Yeah.
moving cars. So that is really an essential role actually for that day.
Okay, terrific. Thank you, Murray. Okay. I think we're done. We'll chat away again
Ben is
next week if
speaking.
there's anything.
I
Ben's been trying
actually
to
have a
talk.
question, not only for me as a volunteer, but also for everyone else. In terms of parking throughout the whole day, I guess we just find our own parking like normal downtown.
Yeah, just a little bit of a warning. I know the area very well because I volunteer at the museum every week. Now I do have a spot occasionally that's marked for volunteers, but when I'm downtown and I want to go to the museum and I'm not using that spot, I often went to St. Anne's. I just want to warn you, St. Anne's is now a government parking space. It's not for public use. So the ones that are available now are basically the ones on the other side of the Parliament buildings. That's quite close. And then the one that I really like, if you come early enough, it's only $7 or $8 for the whole day, and that's the one near the Delta Hotel. That's further down, and it's about a 10-minute walk from. As long as you're not carrying anything, it's fine, and it's the cheapest solution. You get there before 8, and I think it's like $8 or something for the whole day.
Do you mean the Grand Pacific? The Delta is on the other side of the bridge.
Sorry, Grand Pacific. You're right. You're quite right. Yeah.
Okay. Yeah, I know the one. That's right across from where the James Bay Market is, like the Saturday Market is.
Yeah.
That's the one
Yeah.
you're talking about?
Close. Close. Yeah.
Yeah, unfortunately, I mean, we would love to have another $300 or $400 to be able to give everybody free parking. I mean, that would be just wonderful, but we don't. So, and if we'd love to have you come, and we're asking for you to pay for a little bit of parking for one day.
Yeah.
Fair enough.
But that parking lot, Ben, is the best deal if you want to go there. Just a little bit of walking.
That's across, basically, yeah, you walk across the legislature and you're there.
Yep.
Yeah, and actually, Joe just posted, that's my favorite spot. It's off of Superior Street, right behind the museum.
Oh, okay.
Yeah.
But it's quite, like, it's about $2.25 or $2.50 an hour. So if you're there for
but if you want to plug in your electric car, it's free.
Oh,
as long as
yes.
you pay by the hour. But that's why I like it so much.
Anyway,
There you
thanks
go.
for everything. If there's any other questions, just email me and or David, and we can give you more information. We'll be putting out a final note to all of the volunteers to make sure that everybody's got all the information that they need.
Yeah, I mean,
So,
there's setup on Fridays, so for those of you who are leads, please be aware of that. And oh, Lauri, do you have all the requirements for all the activities in Clifford Hall? Do you have people's table needs and things like that?
yes, I think I have everybody's tables and the chairs, and we're up to something like 38 or 39 chairs. So I don't, I'm not, that's going to be a little tricky because they're using them all in another room. So anyway, yeah, we'll see what we can do. Yeah.
Yeah, excellent. Thank you very much.
Thank you. Okay.
Hey, thank you very much for all of that. Lauri?
And I just think the other thing, Marjie, is I'm the GA, the General Assembly,
Oh,
is
right,
coming
another
up
thing.
on May the 2nd and 3rd. Amy Shira Titel is going to be our main speaker on the Saturday night, which is May the 2nd, and that will be at 4:30 our time, because it is 7:30 Eastern time. So in fact, you'll be finished. The whole thing will be finished by 7 o'clock, and you can have an evening after that. But she is an author, a video, she makes films, she writes books, she does all kinds of things, and she's going to be talking about the human side of space travel, and is quite is young. I mean, is a young female person. So I think she'll be really quite interesting to speak to. And then on Sunday, we have for us kind of all day, about from 9 o'clock in the morning to about 2:30 in the afternoon, where there will be workshops kind of all the way through, except for about a half an hour break. And we hope everybody comes, hoping that you've been able to get, if you're a member, you would have had you would have gotten the information to register. It costs $25 as a member to register for both the Saturday and the Sunday. And I hope everybody comes out at least to part of it. You'll be seeing a few familiar faces too, because we've got some Victoriaites that are going to be doing some of the workshops. And David and I will be in the background a little bit doing some hosting and things like that as well. So we're hoping that it's going to be a really good day and a really good time to be able to do it. And eventually, someday, I really hope that we'll be able to be back again in a wonderful city, and we actually will be all together and not online, but we'll see what happens with that. So for now, this is what we have.
Marjie, could you leave a spot for me, maybe about 5 minutes sometime tonight?
Actually, David, would you like to speak now?
I could. So just a couple of things. Let me talk first, and then I'll open up my share. So just a reminder, there's some more things coming up. On May 2nd, we're going to have a telescope clinic, the annual telescope clinic up at the center of the universe. So there's going to be a big focus on making sure that people understand all the different types of telescopes. If you want to come up that night and you want to bring your telescope and make a case for your telescope type, I would really welcome you to do that. It's also the time when we welcome the public to bring, moderately broken stuff or things that need to be maintained, and we see if we can help them do that. I will possibly be bringing some pieces from the Sid's to-do collection with me, or at least at the very least telling people about it. So that's happening on May 2nd. So the last thing I want to tell you about is something I found in this month's Sky and Tell. And I'll just be a second here. And I just there's lots of little things in this month's magazine, but one of them that caught my eye was telescopic asterisms. So these are great for you guys that have small telescopes, like little refractors or binoculars. So there's a number of these asterisms, and in fact, if you want to go even beyond that, Lauri, is the RASC asterism project online someplace? I'm trying to remember.
Oh, completely. Yes, it's
Yeah,
it's the worldwide asterism survey, and Charles Ennis is going to be
right.
talking at the GA about about asterisms and how people find them. So this is exactly perfect. Right in
Yeah,
the
that's
right in
what that's
this time.
wonderful. Anyways, the nice article by Stephen O'Meara, a very well-known journalist, astronomy journalist, and he's picked these ones. Now, I have to admit, I don't know these, so I'll probably be looking for these in the next little while. And I really welcome you to do that because people often wonder, well, I don't have a big telescope and I can't do this, I can't do that. Well, there are tons of asterisms out there, more than you would have time for, right, Lauri?
Yeah, yeah, for sure.
Yeah, more than you would have
Thousands,
time for. Thousands.
thousands. Yes,
Yeah.
thousands.
Okay. So the only other thing I'd mention is there's an interesting article in the same magazine about animal navigation and how animals interact with a night sky. So that's an interesting read as well.
I
Okay.
just put in the World Asterism Project into the chat.
Wonderful. Thanks so much. Yeah. Thanks, Marjie.
Great. Thank you very much. And thank you to all who are organizing and participating in International Astronomy Day, because that's a huge outreach for us. David Payne, do you have a couple of photos to share?
Sure, I'll just share here. So Margie kind of caught me off guard here. I just a few days ago almost finished processing this image. It is, admittedly, it's kind of less dramatic than a lot of the images I like to show. But this one was actually taken in June of last year when I was operating 3 telescopes at the same time, all imaging, and it's taking me this long to move through to June. And I've still got a load of them, but I went back to my notes that I had taken when I had set up this shot, and it's kind of cryptic because it was so long ago. But I said, "Oh, it's got an SH2 sort of emission nebula in it, and it's got a supernova remnant in it." And I had set the framing of this image, it hasn't been cropped at all. I set the framing up so that I could capture both in opposite corners. And yes, this is indeed stellar nursery, a bit of a stellar nursery. I believe this is a star just on where things are pointing, but you can see all the characteristic sort of fluid dynamic irregularities around the edge, and that was kind of cool. If you see a bit of graininess, it's because I sort of overdid it on the detail. And at first I was really excited because I see, and maybe I'll give you the starless version, take with the stars taken out because it's easier to see. I saw this sort of balloon here, and I thought, oh, that must be the supernova remnant I was reading about, and must have seen it in order to set up this image, and must have I was pretty excited at first, and then I saw these just on the edge. I saw these little striations of blue O3 signal.
Oh yeah.
And the other thing that was kind of weird was this strong O3 signal that I was getting in the lower left corner. this is just a light leak on my equipment, so that's nothing. But this strong blue thing coming up down here, and then I said, oh, I've seen this before. So I pulled up an old image, and it's really Wolf-Rayet 154. Both these images are in Cygnus, but then I realized, oh, this is a Wolf-Rayet star moving in space. And I actually, at a cafe a while ago, maybe a year ago, I explained that it had left its atomic sort of shell behind, and that blue in the lower corner was really the bow front from the ejections, and this star must be moving in the frame, or the cloud is moving in the frame, and it left behind this hydrogen alpha shell, which is illuminated by lower energy light. This takes far UV light to ionize the oxygen that you see in blue, but hydrogen alpha is ionized by much weaker light. So it's not a supernova remnant. It's, if anything, it's a Wolf-Rayet star remnant that hasn't exploded. Well, it kind of explodes periodically, but not with the violence of a supernova. So
Dave, are you saying that the same star used to be in that hydrogen bubble on the right, and it moved to the middle of that blue stuff on the left?
Yes.
So, do you have any idea of distances and speeds?
I could triangulate it.
It's amazing.
I'm just pulling up an old image here just to figure out what that balloon really was. And you can tell, like, there's a little lobe on this side, but you can also see that same lobe in oxygen down here. So you're trying to the reason you see this blue here and not here could be that the oxygen atmosphere isn't there, but it could also be that it left some oxygen back here before, but now there isn't the temperature or the UV radiation that lets it show. Wow. So you don't know which one of those two things it is. You could put together a story. It's a bit beyond me to put that together, but and I don't have proof that that's associated with that, but it's just it just fits too easily. It's like it would take quite a coincidence. So going back to this image, the other kind of interesting thing that I want to explore a little bit further is this blue dot that I thought, well, maybe that's planetary nebula, or maybe it's just a reflection, but it clearly comes out in O3 signal. It's not recognized as a star by the AI that takes the stars out of these images. But here it is with this, it's very, very bright. So I'm wondering if it's another Wolf-Rayet star. Oh, not that one. Sorry. Not that one. There it is. Here it is with the star in it. It's not a great, like, I've obviously gone from too much detail, but you do see some blown away hydrogen alpha sort of fronts from it. And it seems to be in a bit of a hole, but I still haven't figured out what the heck that is. So as I don't have a complete story, I like to give a better story. But that's what I have now. Fortunately,
David, your pictures are always just so gorgeously 3D. Like just amazing. Yeah.
And Dave, catching you in mid-process is really part of the fun in this case.
Yeah.
Yeah.
Seeing how you look at things, like that dot at the top was not something that, I think any of us would focus on. So actually seeing your discovery is part of the fun of this tonight.
Yep.
Okay, good. I'll let you know if I figure out what it is. Thanks.
David,
Alex is here.
it looks sort of like a dinosaur.
A dinosaur.
Well, I look for that too. I don't see the dinosaur.
Up there, the tail, the feet, and then there's the face there.
Here's the jaw.
The shell.
Oh, right.
And the horns. Yes.
The head to the right. Yeah.
The left.
Oh, this is a horn? And this is a horn? Maybe I'm not.
Yeah, this is the shape of.
we just fired. Lost the microphone.
Okay.
Thank you, Dave. That's
Thank
great.
you. I got to figure out how to stop share. There it is.
Oh, Lauri, is it worth mentioning the film that's coming that we talked about?
I will do that later. I will do that. It's not till June, so let's get everything else done first. Yeah.
Okay.
Dave, I feel the same way about taking a look at your photograph. It may not be complete, but the story is great, and the story is ongoing. And I'm fascinated whether it's complete or not.
Okay.
Yeah.
Well, Lauri said something. When you start, it takes a while looking at these things to be able to see them in 3D, and we're looking at 3D objects, even though it's a flat screen. But it takes a lot of imagination to see it in 3D.
Mm-hmm. Yeah, and yours do look like 3D, so that really helps us. Being that it's 8:50, Peter, could we put you onto another maybe next week? Or or whatever it is you're going to share, would it be quick?
Yes, I think it would, Marjorie, because all I'm really saying is that Randy has twisted my arm, and even though I don't live in Victoria, I guess I've been attending often enough that Randy asked me to actually host next week.
Lovely.
So I agreed to do it. It sounds like fun. And I'll say a few things about clubs across Canada and so on. What I'd like to do is I'd like to mainly my main presentation, the thing I'm going to prepare myself, will be about the history of the Hume Cronin Observatory here in London. A chance for you folks to feel like you might know it if I talk about it a little bit. And I'll mention a couple other local things along the way. I would like to present about our dark sky observing site, which we have near a town called Fingal, Ontario. But let me see if I can work that out. And then I do have a friend in Arizona who's prepared to talk about his observatory project. And I won't say any more, but you might find it interesting. And then after that, I'm going to leave it to your team to fill in all the local things that I don't know about.
Excellent. We can do that, and we appreciate you being host. And
It'll be
sharing
fun, and I will have
you
I will have a box of chocolate cookies at my side, just so that you don't all feel left out.
Are you going to mail them in time for next week?
No, you're responsible for getting your own there.
Great.
Thank
All right,
you.
it's 8:52. Time to go. And thank you for everyone who shared tonight. This was a brilliant evening. I loved it. I feel so blessed to be part of this creative, exciting community. Do I sound like Randy? Yeah.
Yeah, you're channeling Randy.
I'm channeling Randy. Thank you so much to everyone. It's been terrific. Good night.
Good night.
Thanks, Margie. You're always really fabulous yourself. There you go. Bye, everybody.
Good night.